2022 October, November, paper 12. So let's take a look at the first questions. 1A. Use the list of the formulae MF19 to find the series over here in terms of n. Simplify your answer. So for these questions, very straightforward. You just need to expand the expressions over here, or the series over here, to become r squared plus 2r. Then you do it separately. Get this. So just check the MF19. You can see that this is the formula for the sum of the r square. So this will be the formula for the sum of r. Just direct apply, no need to prove anything. So what you can see over here is that we have the common factor. So usually we will factorize a common factor out. So I will also take the denominator 6 out. So this one you will get 2n plus 1 plus a 6. So simplify it, you get 1 over 6n, n plus 1, and 2n plus 7. So this will be the answer for the number 1A. Done. Now we move on to the number 1B. Express in partial fractions that for these expressions, and after that we want to find the sum. So first of all, we start from here. Since it has two factors, we will have a over r plus b over r plus 2. So that means 1 is equal to the r plus 2, so br. So when the r is equals to -2, you get the b, it will be a -half. Okay, so if when the r is equal to 0, so you get your a is equal to half. Okay, so this is how you find the constant a and b. So now for the series over here, we can just direct apply the result to make it become half over r minus the half over the r plus 2. So you can see that the half is a common factor. We will factorize it out, make it like this to make our calculation easier. Okay, now we just need to list out the terms one by one. So 1 over 1 minus the 1 over 2. No, this one is 1 over 3. Then plus the 1 over 2 minus 1 over 4 plus the 1 over 3 minus the 1 over 5. So you can see that the pattern will be like this. Okay. So that means we're expecting that if you list out 1 over 4 here, 1 over 6 here, then this also can be cancelled. So the pattern continue until the last two expressions. It will be 1 over n minus a 1 over n plus 1. This one is n plus 2. So this one is 1 over n minus 1. This one is 1 over n plus 1. Nothing to cancel. So that means usually I will list out one more terms over here. This is 1 over n minus 2 minus 1 over n again. So you can see that this one can be cancelled. That means anything previously also will behave in such a way. Okay. So at the end, what you left with, these two left and these two remain. Okay, these two remain and these two remain. So this will be equivalent to the half of 1 plus 1 over 3 minus the 1 over n plus 1 minus a 1 over n plus 2. But the question didn't require you to simplify it. Okay, so if you want, you can simplify them, become one fractions. If no, I think this is good enough. Just make it like this. It's good enough. Of course, if you have the time, you can combine them, become y fractions. Okay, so this will be the answer for the number 1b. Now we're moving on. Question C is to find the sum to infinity. So the sum to infinity over here, we just write that the limit of n is approaching to infinity for the result that we have here. This result, we just copy down. 3 over 4 minus of 1 over 2 of n plus 1 minus of 1 over 2 of n plus 2. So when the n approaches to infinity, you get this one as 3 over 4. This will be 0. Approach to 0, this one will be approach to 0. So just like that, done. So this will be the number 1C. And moving on, we will be having question number 2. Equations over here, x power 4 plus 3x squared plus 2x plus 6 equal to 0, where the roots are alpha, beta, gamma, and delta. They want you to find the new quadratic equation where the roots are 1 over alpha square, 1 over beta square, 1 over gamma square, and 1 over delta square. Then after that, we want to find the sum of these 4 roots over here. So what you need to do is, first of all, we just let the y equal to the 1 over x squared. Then your x will equals to the square root of 1 over y. So it will be y to the power of negative half. I usually prefer to write them in the power of negative. So this is the substitutions. So from here, x power 4 plus 3x squared plus 2x plus 6 is equal to 0. So you will get the y power negative 2 plus the 3y power of negative 1 plus 2y power of negative half plus 6 equal to 0. So I go and multiply everyone by y squared. I want to make the power become positive. So it will be 1 plus 3y plus the 2y power of 3 over 2 plus the 6y squared equal to 0. So we separate them. The one with the power that is a fractions is one side. The rest of them where the power is the positive integer, we will put it at another side. Okay, so this is what we have at the moment. Then we just need to expand them. We just need to square both sides. So we square both sides, you get a 4y cubed. This will be 6y squared minus plus the 3y plus 1. Okay, I squared both sides already, so all the negative, eventually after you square it, all the negative will become positive. So to save time, I just direct make it become positive. So now this left-hand side, nothing to do anymore. We just write it down only. But right-hand side, we will need to expand them properly. This is 3 terms here. So we have to expand them carefully. So you have a 36y to the power of 4 plus the 18y cubed plus the 6y squared plus the 18y cubed plus the 9y squared plus the 3y and plus the 6y squared plus the 3y plus 1. So if you expand and simplify, you will get 36y to the power of 4 and then plus the 36 minus 4, 32y cubed. Then 21y squared. And then plus a 6y plus a 1 equal to 0. So this is the new quadratic equation that the root is 1 over alpha squared, 1 over beta squared, 1 over gamma squared, and 1 over delta squared. These are the new quadratic equations. So from the equations over here, 1 over alpha squared plus 1 over beta squared plus 1 over gamma squared plus 1 over delta squared, that will be this negative 32 over the 36. Simplify it, all can divide by 4. You get 8 over 9. Negative 8 over 9. So, done. That will be the answer for the number 2, part A. Number 2, part A. Okay. So now we move on to the question number 2, part B. So the expression over here looks a bit scary. Okay. So find the values of beta square, gamma square, delta square, plus alpha square, gamma square, delta square, plus alpha square, beta square, delta square, plus alpha square, beta square, gamma square. Okay. Okay. So how do you find it? Okay. Then beta square, gamma square, delta square, plus. Okay. So it's a bit troublesome to pronounce it out. Okay, this one is alpha square, beta square, gamma square. Okay, so the trick over here is that all you need to do is just to make this become, you can see that over here, you can see that everyone, you're supposed to have 4 roots, right? But each and every terms over here, it only contain 3 roots. So what you need to do is just multiply the missing root. This is the missing root. Okay, and just divide the missing root. So these two, after you cancel it, you still get back the same thing. So you will do this for the rest of the 3 of them. So at the end, you will get alpha square, and beta square is missing. So you multiply the beta square inside, but you divide the beta square at the same time. So this one, the gamma square is missing. You multiply the gamma square inside, and then you divide the gamma square. Same thing happened over here. The delta square is missing. So this is what you have. So now after you're doing this, you can see that all your numerator, they are having the same expressions already. All you need to do is just to factorize it out. Then this is 1 over alpha square plus 1 over beta square plus the 1 over gamma square plus the 1 over delta square. So this is the trick. So you can see that this is the product of the 4 roots. The product of the 4 roots, if you refer to here, of the square of the product of 4 roots, you refer to the original. This is alpha, beta, gamma, delta is a negative, negative, positive, negative, positive, negative, positive, positive. So it's positive 6, positive 6. So over here is positive 6. Negative, positive, negative, positive. Yes, correct. Positive 6. So this one is a 6 square. This one is from the part A just now. From the part A just now. Part A just now, the answer is negative 8 over 9. So you just press the calculator, then you can get the answer as negative 32. So this will be the answer for the number 2B. Done. Now we move on to the number 2C. So now they are looking for alpha power 4, 1 over beta power 4, plus 1 over gamma power 4, plus 1 over delta power 4. Well, this is actually the 1 over alpha square square, 1 over beta square square, plus 1 over gamma square square, plus 1 over delta square square. So you need to know the trick is you just need to do it like this. This one we if you have been practicing this kind of questions many times, so you should be able to understand why we do like that. So this one will be, or this one will be troublesome, 4 of them. So you have total 6 of them here, okay? Because 4C2, 4C2 you have 6. So you have this alpha square, delta square, gamma square, alpha square, delta square, plus the beta square, gamma square, plus the beta square, delta square, plus the 1, 2, 3, 4, 5, 6. The last one is the gamma square, delta square. Okay, so this one is a bit troublesome. So over here, this is what we have found from the part A, negative 8 over 9. This is the sum of the product of 2 roots. Sum of the product of 2 roots is coming from here. sum of the product of two roots is coming from here. Okay, so it's a 21 over 36. Okay, 21 over 36. So it will be 21. I forgot to times 2 here. So 2 times the 21 over 26. Okay, 36, sorry, 36, not 26. So now the rest, just press a calculator. You can get the answer as negative 61 over the 162. Done. So this will be the answer of the question number 2. And moving on, we have question number 3. Have a matrix M. The M is a product of two different matrices over here, where the K is a constant and K not equal to 0 or 1. The M represent the sequence of the two geometrical transformations. State the type of each transformations and make clear the order. Okay, they want the order to be clear. Okay, so make clear the order in which they are applied. So this will be the first one, followed by the second one over here. Okay, so for the first one, this you can check it. I mean, you can actually memorize this form. So if you have been practicing the transformations, so this one actually is a shear. So we just say that is a shear with the y-axis fixed. Okay, the y-axis fixed. That map. Oh, sorry. We don't say width. We just say that shear, the y-axis fixed with the 0.10 map to 1K, followed by now the second transformation. This second transformation is stretch, followed by stretch parallel to y-axis with the scale factor K. The scale factor K. Okay, so this is the answer for the 3 part A. So now we go for B. Write the M inverse as a product of two matrices, and neither of them is an identity. Okay, so over here we just let this as a this is the A lah. I let this one call A. I let this one call B. So A is a 100K. A is a 100K. Then B is a 1K01. So I want to find the A inverse. A inverse is 1 over K. These two swap. Then the B inverse is 1 over 1. These two swap. This one put negative. So you get this. Okay. So the M is equal to the AB. So the M inverse is equal to the AB inverse. So you need to remember the rules. Okay, this one you have to remember it. The rule says that if you have an AB inverse, then it will be the B inverse multiplied by the A inverse. Okay. So we will no need to prove it. We just need to know that we have a rule like this. So over here, it will be the B inverse multiplied by the A inverse. Maybe we can multiply the K inside, make it like this. Okay, so this will be your M inverse. So you can see that M inverse can be written like this. That means neither of them is identity. Okay, so done. We have found we have solved the part B. Now we're moving on to the part C. But see, they ask you to show that the invariant points of the transformation represented by M lie on the line of this. Okay. So what is your M? Just now we didn't multiply the M. So M, we just write down this one again. So we're going to expand them by the product of two matrices. So you will get this one as the 1, this one as a 0. This is a K square. This is a K. Okay, so this is the M. If you put them as a 1 matrix. So now we want to find the invariant point. Show that the invariant point is lie on this line. So you can see that actually invariant point must be in the invariant line. So if I want to find the invariant point that lies on this line, that means actually this will be the invariant line. So where can you find the invariant point? The invariant point must only, you can find it in the invariant line. Okay, so that's why this question, in another words, is actually we are looking for invariant lines. So we just let our invariant line as a y equal to the mx. Then your image will be the y equal to the mx, uppercase y, uppercase x. So if you take the m, and if you transform any point that on this invariant line, you will get this. Okay, so over here, it will be changing the y to become mx, changing the x, changing the y here become mx. Okay. So over here, you just get this. This is the x equal to x. This is the k square plus the km is equals to the mx. So over here, just take this as equation 1, take this as equation 2. So you just take the 1 divided by 2. You get 1 divided by k squared plus km equal to 1 over m. So you get m is equal to k squared plus km. So what is your m? Your m, it will be 1 minus k squared. Then your m is a k squared divided by 1 minus k. So because of the invariant point must lie on invariant line, okay, so therefore invariant line, what is the invariant line? An invariant line is a y equal to the mx. So therefore, shown. Okay, just like that, done. So this will be the answer for the question number 3, C. So we move on. Still have question number 3D. Okay, so this one, another questions. The triangle ABC in the XY plane is transformed by M onto the triangle DEF. Okay. So ABC transformed to DEF, that means this one is object, this one is image. Find the value K which the area of the triangle DEF is equal to the area of triangle ABC. Find the value of K. Okay, so if the if the area is equal, that means we know that the formula is that the area of image is equal to the modulus of the determinant of the transformation multiplied by the area of our object. Okay, we know this relationship. So in order to make them equal, that means the determinant m must be equal to 1. Okay, in order to be equal, the determinant m must be equal to 1. Okay, so I think we will start from the determinant. Okay, we start from the determinant m. So your m just now was, what was the m already? The m just now refer back. M is 10k square, 1k square, 0k. Okay, so your m is 1k square, 0k. Your determinant of m is a k. Okay, so given that the area of the triangle DEF equal to the area of triangle ABC. Okay, that means we know that the modulus of a determinant m must equal to 1. Okay, then the modulus k must equal to 1. Okay, then the k must equal to plus minus 1. Okay, but you can see that over here they just mentioned value is a singular, not plural. So we need to check again the questions. Any information about the k? They say that the k cannot equal to 0 or 1. K cannot equal to 0 or 1. So for this reason, okay, so because of k not equal to the 0 or 1, therefore your k must be negative 1. So this will be the answer for the question D. This is the answer for the question D. So now move on. Question number 4. Okay, just now question number 3. Yeah, sorry. Okay, this one is question number 4 right now. The function f is given that such that the f second prime is equal to fx. Proved by mathematical induction that for every positive integer, the differentiations relationships over here is true. So what we need to do is that we start from n equal to 1. So when the n is equal to 1, then this one it will be the ddx of xfx. So this one is keep the left, differentiate the right, plus keep the right, differentiate the left. Okay, so is it true for the relationships over here? So what you need to do is just to show that this plus the 2, 1, minus 1 fx. So it's true for n equal to 1. Now we assume true for n equal to k, which is the d power 2k minus 1 over the dx power of 2k minus 1 of the xfx is equivalent to, is the same as the equals to the xf prime plus the 2k minus 1 fx. Okay, so this is what we assume true. So now we go for the third statement. When the n is equal to k plus 1. So over here, you have to be aware that when the n is equal to k plus 1, and when you put inside here, when you put the k plus 1 inside here, it will become the power of 2k plus 1 minus 1 over the dx 2 of k plus 1 minus 1. So this actually will give you d 2k plus 1 over the dx 2k plus 1. So that means you have to differentiate 2 times. Okay, you have to differentiate 2 times. You can only get to here because 2k minus 1, how do you get 2k plus 1? You must pass through 2k first. Okay, so in order to get this, you need to differentiate 2 times. Then you can only get until 2k plus 1. So this is something that you have to be aware of, else you were not able to get the answer. So ready? Now we will go and differentiate this. So that means I differentiate this on top of the result here, on top of this result. Okay. Then I get differentiate this. So from here, you keep the left, differentiate the right, plus keep the right, differentiate the left, plus the 2k minus 1 of f prime. So because they told you that this is a fx, so this one is x fx plus the 2k of f prime x. Okay, so this will be the d2k dx power 2k x fx. Okay, so this doesn't fulfill the statement. It doesn't matter because this is not what we want. We are looking for d2k plus 1, not d2k. So that means we need to differentiate the d2k dx power 2k again. So this is what we want. So this one, it will be differentiate the x fx plus the 2k f prime. So you keep the left, differentiate the right, plus keep the right, differentiate the left. Okay, then this one you will get 2k f double prime. Okay, so because of they told you that f second prime is a f. They told you that the f second prime is a f. So over here we will get this as a x f prime plus the 2k plus 1 of fx, because of the f second prime is equal to f, because of the information given. So is it true for n equal to 1, n equal to k plus 1? Yes, it's true. Okay, so therefore it's true for n equal to k plus 1. So conclusion, by the BMI is true. By the BMI, differentiate 2n minus 1 over the dx 2n minus 1 of x fx is equal to the x f prime plus the 2n minus 1 fx. Okay. Okay. This is equals for every positive integer n. Positive. Okay. So, or maybe we can say that if f prime equal to f, then this is true. Okay, so that will be more proper. The statement will be more proper. So this will be the answer for the question number 4. And moving on, we have question number 5. C has a polar coordinates, polar equations of r equal to the a secant square, where a is a positive constant. 0 to pi over 4. Sketch C, stating the polar coordinates of the point of intersections of C with the initial line and also the half line, theta equal to pi over 4. Okay. So we usually when we need to sketch the polar curve, polar equations, we need to build the table. So this is the theta, okay, and this is the R. So the theta start from 0 and then until pi over 4. Pi over 4 is a 45 degree. Maybe we can put in a 30 degree in between. So when we replace substitute 0 inside here, secant 0 is a 1, so your R is a. So, and then you put pi over 6 inside. Pi over 6 is actually 3 over 2 over 3, 4 over 3, 4 over 3a. So this is 4 over 3a. Then if you put pi over 4 inside, so it's a 2a. So you can see that the a is increasing. The a is increasing. So what you need to do is you just roughly estimate. This is theta equal to pi over 4. This is a 0. This is the theta equal to the 0. So your graph only exists at this portion. Okay, your graph only exists as this portion. So what you need to do here, maybe we can add in one more 30 degree here. Theta equal to pi over 6. So we measure when it's a 0 is a. So when it's a pi over 4, it will be 2a somewhere here. So this is 2a. Then in between, we can just plot it. It will be somewhere here. So this is a bit, how to say, a bit controversial. Some students, they draw like this. Okay, some students will draw the graph like this. Some students will draw the graph like this. Then some students will draw the graph like this. Some students will draw the graph like this. Okay. So, but because we actually not able to fully understand the graph unless we have more points. If you have more points, that means if you divide them into the pi over 12, or you just divide this into more detail, then you can only plot the graph more accurately. But since we only have 3 points over here, so we have to be careful. Okay, so the actual answer is that the graph should look like this. So unfortunately, it's actually a bit difficult to tell by looking at the 3 points over here. So this one, in exam, you have to be careful. You have to be careful. Actually, there's no other way to check unless we unless we plot more points. Then we can only confirm that our graph look like this. It's a curve. Okay, the curve look like this. But many students, they will actually draw the graph like this. So this is something you have to be careful with. So this is the graph. Okay, so this is the graph. So done. They want to find the point of intersection. So the point of intersections, it will be R theta and R theta. Okay, so these are the 2 points that we are looking for. The sections with the initial line and also the half line of theta equal to pi over 4. Okay, so this will be the answer for the part A. Now we move on to the part B. Find the maximum distance of a point C from the initial line. So the maximum distance. So initial line, this is the initial line. This is the initial line. So the maximum distance we have to find the maximum distance. We have to find the x dy d theta equal to 0. So maximum distance, we have to find dy d theta equal to 0. Okay, so in order to get dy d theta, okay, so we are looking for dy d theta. So first of all, your r is equal to the a secant square. And we know that the y is equal to the r sine theta. So I have to multiply sine theta. Multiply sine theta, I will get this. Okay, so this is what we have. So your y is equals to the a sine theta secant square theta. Okay, but actually, you can see that very obvious. This is the maximum distance. You can see that this is the maximum distance. This is the y max. Okay, you can see that very obvious. This is the y max. Okay, so there's no need for me to find the dy d theta anymore. Okay, so the y max, when the theta equal to pi over 4, okay, the y max will equal to the a sine pi over 4 and secant square pi over 4. Okay, you can see that from the graph. From the graph, we know that it's very obvious. This maximum of the height is actually at the theta equal to pi over 4. So this sine is 1 over Z2. This one is the Z2 over 1. So it's a 2. So the answer is 2 over Z2. 2 over Z2 is a Z2A. Okay, so that is your answer, the Y max. Okay, now we go for the question C. Find the area of the region enclosed by the C, the initial line and the half line theta. Okay, enclosed by the C. So over here, we are looking for this region. Okay, so we are looking for this region. So this region is C. The area will be equal to the half integrate from 0 to pi over 4 r squared d theta formula. Just apply it. What is your r square? Just put the r is equal to the a secant square theta. So you will get this one as the half 0 to pi over 4 a square secant power 4 theta d theta. So how are we going to integrate secant power 4? We know that we can integrate secant square. So to integrate secant power 4, we can actually make it like this. Secant square, secant square. So over here, this one if based on experience, actually based on experience, we know that these situations we need to use integration by part. No need. Can we use integration? No need to use integration by part. Sorry, yeah. Based on experience, we need to know that the secant square can be written as 1 plus tangent square. We need to know that secant square can be written as 1 plus tangent square. So this one is a 0 to pi over 4. Secant square theta, 1 plus tangent square theta. Like this. Okay. Then you expand them. Okay. Plus the tangent square theta, secant square theta, d theta. So this one we can integrate directly. Okay, this one we can integrate directly. This one we will need to use the power n rules. So that means the f prime fx power n is equal to the fx power of n plus 1 over n plus 1. So over here, the power is 2. Because when we differentiate tangent, we get secant square. So you need to know it. So this one based on practice. So most of the time for integrations, we very much depends on our experience. We need to practice a lot, then we can only see that or have the idea how to do it, how to integrate it. So secant square integrate, you get tangent. So this one is a tangent cube theta over 3. Direct integrate. There's no step in between. Direct integrate will do. So right here, you will have tangent pi over 4 plus the tangent cube pi over 4 over 3 minus a 0. So tangent pi over 4 is a 1. So it will be 1 plus 1 over 3. 1 plus 1 over 3, 4 over 3. So you get 2 over 3 a square. Okay, so that will be the area for the region bounded by the C initial line and the theta equal to pi over 4. Okay, so this is the answer for the C. Move on. We have question D. They want you to find the Cartesian equations of C in the form of y equal to fx. So for this question, actually not difficult. You just need to remember that the x equal to the r cos theta, y equal to the r sin theta, and x squared plus y squared is equal to r squared. Just need to remember these three things will do. Okay, usually just these three things is enough. So what is the questions? What is the equation again? Equation is r equal to the a secant square. R equal to a secant square. So we have r equal to the a secant square theta. So we have r cos square theta is equal to a. So like what I mentioned just now, okay, I think I should erase it so early. We know that the r cos theta is x. We know that the r sin theta is a y. We know that the r square is a x square plus y square. So what you need to do is, we have a square here. I don't have a square here. So something is missing. All I need to do is to multiply r. For both sides, you get r square cos square theta is equal to the AR. So this will be the same as the x square equals to the A. Your R will be the square root of x squared plus y squared. Okay. We will not going to leave it like this. This is the answer already actually, but the question specifically wants you to leave the answer y in terms of x. So what you need to do is you need to square both sides. Okay, then you bring it to the other side. You get x power 4 over the a square minus the x square. Y is equals to the square root of the x square over a square. Then you get x square minus the a square. Minus wait for a while. Okay, sorry. This is x square. Take the x square out. Okay, we can leave it like this. Okay, so over here, your y is equal to the x over a square root of x square minus a square, correct? Okay, so that will be the answer. But some of you may ask, shouldn't we write y equal to the positive negative square root of x square over a square, x square minus a square? Shouldn't we write like this? Well, actually, is we check again. because the graph that we have is on the positive side. The graph that we have is positive side because the theta is from 0 to pi over 4. So we will not going to get negative value. Okay, we will not going to consider the negative value. So we just write like this will do. We will not going to consider the negative value. So just write like this will do. Okay, so this is good enough. The answer. Okay. Yeah. So okay, so this is the answer. Done. Then move on. We have question number 6. Q is on the L2, that the PQ is perpendicular to the L1 and L2. So right here, I will rewrite again the line L1 in the matrix form. This is what I usually do. Like this. And the line L2 in the matrix form also. 0 to 6 plus the mu of the 1 to negative 2. So the question actually mentioned that the line L1 contain the point P, and the line L2 contain the point Q, and then they say that the PQ is actually perpendicular to each other. Okay, PQ is perpendicular to the line L1 and L2. So actually this is the shorter distance between the two scale line. Okay, so we can actually see that the line L1 and L2, they are scale. Okay, but we do not need to prove it because the question not require us to prove it. So we can see that the PQ is actually the distance of the two scale line, shorter distance of two scale lines. So we just need to apply the formulas for the shorter distance between the two scale line. So what we need to do is we let this one call OA. This one called OA. 201. And this one called OB. This is called OB. So we go and find the AB. AB will be the B minus A. Okay. So let's say the A is here. The B is here. So we will just apply the formula if you still remember the formula. Okay, so over here, I just apply the formula directly. We need to find the normal vector first, the normal vector for the L1 and L2. Okay, so we just take the L1 directional vector. For L1 is a 1, negative 1, 2. Okay, and the directional vector for the line L2 is a 1, 2, negative 2. We do the cross product. So we have a 2 minus 4, negative 2i. Then the j will be the negative 2 minus 2, negative 4, positive 4j. And the k will be 2 plus 1, 3. Okay, so this will be my normal vector. And the shorter distance, that means the PQ, is actually equal to the modulus of the normal vector negative 2, 4, 3 dot with the AB, square root of the magnitude of a normal vector 4 plus 16 plus 9. So over here you can get this one negative 4 plus 8 plus 15 divided by negative 2. So this one is a square root of 29. So we press the calculator. Oh, so sorry, this one is positive 4. I make a mistake. So this one, it will be 27 over square root of 29. This will be the distance of PQ. Okay, so this will be the length of the PQ. Or you can press the calculator into this 3 significant figure. It will be 5.01. But usually I prefer exact value. So then this will be the answer for the 6A. Now we move on to the 6B. So we have a pi 1, the plane pi 1 contain PQ and L1, and plane pi 2 contain the PQ and L1, L2, okay. So, okay. So actually the PQ, the PQ is, this one is parallel to PQ. Okay, so we can use PQ to represent this. We can use PQ to represent the direction of PQ is 2i negative 2i plus 4j plus 3k. Okay, so over here to find the pi 1 in the vector form, it will be r equals to the a plus s plus d. So this one is the is contain PQ and L1. So I do not have P, I do not have Q actually. I only have L1. L1 contain this point. So it's a 201. So over here we write 201 here. And the directional vector for the line L1, the directional vector for the line L1 is 1, negative 1, 2. 1, negative 1. And the directional vector for PQ, the directional vector for PQ just now was negative 2, 4, 3. And this will be the answer for the question B part 1. The question for B part 1. Okay. So now we want to move on to the pi 2. We want to move on to the pi 2. Pi 2 is they want you to leave the answer in the Cartesian form. Okay. So we need to find the N2. So similar to pi 1, actually just now pi 1 is in the vector form. So you can actually just need to take the cross product, okay, the cross product. Then you can find the normal. But this is a pi 1. So we're looking for pi 2. So if it's a pi 2, it's a cross product between the directional vector for the PQ. This is the PQ, directional vector for PQ. Cross with the directional vector for the line L2. Directional line for L2 is directional vector for the L2 is a 1, 2, negative 2. So we do the cross product. Over here, you will get negative 8 minus 6, negative 14i. Then the j will be 4 minus 3. 4 minus 3 is 1, negative j. Then the k will be negative 4 minus 4, negative 8k. Okay, so this will be the normal vector. So for pi 2, the Cartesian equations, just put a 4 bracket here. This will be x, y, z. This will be the normal vector. We actually can ignore the negative. Factorize all the negative out. You can make it like this. So this is a fixed point position vector. So the position vector for the line L2. If you go for L2, the point over here will be this point, 0 to 6. 0 to 6. So we put here 0 to 6. Then we can get the answer. So you have a 14x plus y plus xz equal to the 0 plus 2 plus 48. It's a 50. So this will be the answer for the B part 2. Now we move on to the C. The acute angle between the pi 1 and pi 2. Also the acute angle between pi 1 and pi 2, that will be easy. But first of all, I need to find the normal vector for the N1. Okay, because we already have N2. We already have N2. But it's just that the N1, just now N1, I don't have N1, need to take the cross product between these two. Cross product between these two, we can only get N1. So 1, negative 1, 2. Okay, 1, negative 1, 2, and negative 2, 4, 3. Cross product. So it's negative 3 minus 8, negative 11. So it's 3 plus 4, negative 7j. Then 3, 4 minus 2. So it's a 2k. That is your N1. Okay. So to find the acute angle between the pi 1 and pi 2, we just take the N1 dot N2 magnitude of n1, magnitude of n2, and then cos theta. So n1 is negative 11, negative 7, and 2. This will be 121 plus 49 plus 4. Your n2 just now was 14, 1 and 8. By the way, they mentioned acute angle, so we put modulus. So 14 square, 196 plus 1 plus 64. Okay, so your cos theta will be equal to the modulus of negative 154 minus 7 plus 16 divided by the square root of 174 and square root of 261. Okay, like this. And then press a calculator, then you can get the answer as 47.1 degree. Okay, you can get the answer 47.1 degree. So this will be the answer for the question number 6C. Move on. Question 7. Okay, so question 7. C, where the y is equal to the x squared minus x over the x plus 1. So we want to find the equations of the asymptote of C. So we just take we want to find the vertical asymptote. So to find the vertical asymptote, we just take the denominator out, let it equal to 0. You can get this. So this is your vertical asymptote, VA. So to find the horizontal asymptote, we just need to put the limit of x approaching to infinity of x squared minus x over the x plus 1. Over here, you get, so this one is improper fractions. So we cannot find this one yet. We need to use long division. Or if you do not want to use long division, you can do it like this. Okay. Minus the 2x. Okay. Then plus with the 2. Then you can get y equal to the x minus 2 plus this. So your y is equal to the limit of x approach to infinity of this. So your y, your horizontal asymptote will be the y equal to the x minus 2. Okay, so this will be your answer for the part A. So we have vertical asymptote and horizontal asymptote. Done. So now we move on. This one not this one not horizontal asymptote. We're supposed to call this one oblique asymptote. We're supposed to call this one oblique asymptote. So OA. Move on. Exact coordinate of the stationary point. So to find stationary point, we will start from here. Actually, every time when we can change into this form, differentiate from here to get the stationary point will be easier. So x minus 2 over the 2 over the x plus 1, you find the dy, dx over here, it will be 1 minus the 2 of x plus 1 square. Dy dx equal to 0. So you get 2 over the x plus 1 square equal to 1. So you get the x plus 1 square is equal to 2. So your x will be equal to negative 1 plus minus 2. So when your x is equal to negative 1 plus 2, what is your y? When the x is equal to negative 1 minus 2, what is your y? So we need to replace it, the x inside here, to go and calculate the value. So over here, this one needs some, you need to do it, solve it manually. Okay. So over here, it will be a bit troublesome. The value is not so nice. So we will going to get negative 1 plus 2 minus 2 plus the 2 over the 2. So this will be the negative 3. Negative 3 plus 2 is 2. Then when the x is a -1 minus a 2, your y going to be this. So it will be -3 minus 2 is a 2. Okay, so your stationary point, you have two. They are -1 plus Z2, -3 plus 2 Z2. Another one is -1 minus Z2, -3 minus 2 Z2. So these are your stationary points. Done for the part B. Moving on, we want to sketch the graph and then state the intersections with the axis. So to state the intersections with the axis, what you need to do is we copy this equation down first. When x is equal to 0, your y is a 0. Your y equal to 0, then your x is a 0, and your x squared minus x is equal to 0. Then your x is equal to 0 and x equal to 1. Okay, so you have the intercept, which is a 0, 0, and the 1, 0. Okay, so these are the two intercepts that we have. So from here, we are ready to sketch the graph. I draw in freehand, but in exam, you should draw it better than me because you have ruler and everything. So draw with a proper scale. Okay, so this one is the 0, and then this is 1, this is 2, this is a -1, -2. This is a 1, this is a 2, and -1, -2, and so on. So what is vertical asymptote? Vertical asymptote is -1. What is your oblique asymptote? Oblique asymptote with our OA is this. So it's a -2. It will be a 2 here. So this will be my oblique asymptote. So we need to draw it nicely. Okay, so seems like I need to extend a little bit longer here. So since you are having the intercept 0 and 1 right over here, then you are having the stationary point -1 plus 2, -1 plus 2, and -3 plus 2 2. Okay, so this one you need to calculate it yourself. So this value, it will be somewhere here. You can see that the graph actually look like this. Okay, so you'll be having a minimum point here. You're having a minimum point here. Make sure you draw the features of the asymptote. Okay, so this is your minimum point. It's a bit difficult to show. This minimum point, it will be -1 plus 2 2, and -3 plus 2 2. And you have a maximum point over here. Okay. Need to show the features of the features. So this maximum point is a -1 minus 2 2, and -3 minus a 2 2. Oh, this one is without the 2. Okay, so this will be the maximum point and the minimum point. This is the x, this is the y. Okay, erase. So this will be the graph of y equal to the x squared minus x over the x plus 1. Done. Okay, so we are done with the C. So the graph look like this. Maybe I zoom out a little bit for you to see the whole pictures of it. So this is the full graph of the C. So now we move on. We want to go for the part D. Part D is to put the modulus. Okay, so if we put the modulus, then this one will be reflect. It will be reflect. Wow. The x-axis. So you can imagine. Okay, so if you reflect about the x-axis, so what will happen to the graph? So this one, I just redraw again. So we need to draw it carefully. So again, because over here I draw it freehand, so I'm not able to have a proper scale. So, but in exam you can have a proper scale. So this one, you try to sketch the graph properly. So this is a 1. This is a 2. Okay. So this is a -1, like this. So your asymptote, actually by right, this is a -1, -2. By right, you are having the oblique asymptote go like this. Okay. But it will reflect. Okay. Your graph is supposed to be like this. Minimum here. Okay, then this one had to reflect. This portion had to reflect. So over here, I erase it. I reflect the graph. Okay, so this part, this portion has been reflected. And this is a -2. So this point, this is a -1 plus a 2. And after you reflect it, this is a -3 plus 2 sub 2. Okay, but I think never mind. I will not going to show it so detailed here because the main thing now is we want to solve the inequality. Okay, so this just now the minimum part has been reflected. So your graph will be, your oblique asymptote will be reflected like this. Your oblique asymptote also will be reflected. Okay, oblique asymptote also will be reflected. It will be somewhere like this too. Not reflect like this. Your oblique asymptote will reflect over here. So your graph will be something like this. Your graph will become something like this. So this point, this will be -1 minus a 2. This will be the modulus of -3 minus 2 sub 2. Modulus -3 minus 2 sub 2 will be 3 plus 2 sub 2. Okay, but also I think there's no need for me to show this anymore. So I just reflect over here only. So now we take a look at the questions. What do we want? We want this to be less than 6. Oh, okay. So less than 6, actually, by the way, just now it's important to know that this one 3 plus 2 sub 2. 3 plus 2 sub 2 is actually less than uh, less than 6. It's actually less than 6. Okay, so 6 will be somewhere here. 6 will be somewhere here. Okay. So it over here. Okay. So now we want to have the line y equal to 6. The line y equal to 6 is somewhere here. The line y equal to 6 is somewhere here. So you can see that eventually if you extend this graph, eventually it will intersect 1, 2, 3, 4. Eventually you will have intersections between the y equal to 6 will intersect with the modulus graph. 4 value, okay, 4 values. So we need to find out all the 4 values over here. So how are we going to find out all the 4 values? But wait for a while. I will erase this one first. I want to make my graph look so messy. Not required to write 6 over here as well. Okay. So what I need to do is, first of all, I let the modulus of x squared minus x over the x plus 1 equal to 6. Then I will get two equations. One is equal to the positive 6. One is equal to the negative 6. Another one is a negative 6. So this one you solve it. 6x plus 6. This one if you solve it, negative 6x minus 6. So you get x squared minus a 7x minus a 6. This one you get 5x plus 6. So this one is a x plus 3, x plus 2. This one, we're not able to factorize it. So it's a negative b plus minus of b squared minus a 4ac divided by 2a. So you will get this as the 7 plus minus square root of 73 over 2. Okay, so this one you will get x equal to negative 2, negative 3, and negative 2. So if you put them in a number line according to the sequence, so you can see that actually the smallest is negative 3, negative 2. Negative 3, negative 2. This is a 7 plus 73 over 2. And this is a 7 minus a 73 over 2. If you arrange them in the sequence, okay, you can see that. If you arrange them in the sequence, you can see that this is the order from ascending order. So you can see that just now I draw the 6 over here, right? We want the 6 is actually greater than the graph. Okay, so this portion, the 6 is greater than the graph, and this portion also, that the 6 is greater than the graph. Okay, and we have found that this is a negative 3. We have found that this is a negative 2. We have found that this is a 7 over 2 minus the square root of 73 over 2. We have found that this one is a 7 over 2 plus the square root of 73 over 2. So you can see that the answer will be here. Okay, maybe I use color. The answer will be here and here. Okay, so you just say that from the graph, So your x will be between -3 and -2. And 7 minus 73 over 2. 7 plus square root of 73 over 2. Okay, so this will be your answer. This will be your answer. So done. Yeah, erase this. Make it back to normal. The graph. This one erase. This one erase. This one erase. So this is the y. This is the graph of y equal to the modulus of x squared minus x over the x plus 1. This is the graph of y equal to 6. So you can see from the graph over here. So your answer will be this and this. So done. And this will be the last question for this paper. No more. So I'll stop the video here. I'll see you next time and bye-bye.